Okay, so this talk is about a basic problem that arises in the interpretation of specifically plural definite descriptions. And the problem is this. So if you look at a sentence like Peter read the, oh, sorry. So what did I do? So that should be Peter solved the math problems he was assigned. And that tends to be interpreted that as meaning Peter solved all of the math problems he was assigned, or nearly all. You know, there may be a few exceptions, but that's more or less a universal reading. Now, if you add a negation, so you get 2, Peter didn't solve the math problems he was assigned, that tends to be interpreted not as the logical negation of the first one, not as meaning that he didn't solve all of the math problems he was assigned, which would be true, you know, if he solved most of them, but not all of them, but really as meaning that he didn't solve any of the math problems he was assigned, or maybe very few, something like this, right? So that's the basic problem. And just, that's not a matter of scope. So you could think, what's going on maybe that the definite description in the sentence 2 scopes over negation. That's not a good analysis. For instance, if you look at a more complex case, no student solved the math problem he was assigned where the pronoun is bound by no student. So, the math problems he was assigned is trapped in the scope of no students. You still have, a reading that's in a way surprising, which is something like every student failed to solve any of the problems he was assigned, or at best solved very few. And that's in fact not restricted to plural predication. So even if you look at something like the wall is blue, that's understood as meaning that the wall is entirely blue or nearly entirely blue. And if you look at the wall isn't blue, if the wall is half blue, that's not clearly true. But I actually won't talk about such cases. I hope my account will be able to extend to such cases, but I'm not even sure so far. So Loebner, in various publications, accounted for that by saying that when you apply a predicate P to a plurality X, specifically a distributive predicate, that yields a presupposition that X is homogeneous with respect to P. And by this he means, that either every part of X has the property P or no part of X has the property P, right? So he calls that a presupposition. What he really means is just that P of X is neither true nor false if the homogeneity condition is not met. Right? So now, for Peter didn't solve the math problems, what's going on is, and that's not actually the right representation, because here I've scoped it out, and I don't know why he did that. No, that's fine, actually. No, you scope it out. That doesn't change anything. It's a referring expression. So, but what you get is that, for this to be true, Peter shouldn't have solved all of the math problems, but since this presupposes that he solves either all of them or none of them, because, the predicate lambda x, Peter did not solve x, triggers this homogeneity presupposition, the claim that he didn't solve all of them, given this presupposition, amounts to the claim that he solved none of them. So that's the account. Now, what I will do with this, so I will argue against a presuppositional account in the sense that even though I will use trivalent semantics, I will argue that this homogeneity condition is not a presupposition in the usual sense. That is, in particular, it doesn't project like presuppositions. I will review and improve on another proposal by Krivka in terms of the stronger meaning hypothesis, and to improve on this, I will adopt a supervaluationist view, and I will explain what that is. And then I will talk about this fact that I mentioned in the beginning, that in fact, if you look at really the truth conditions for John solved the problems, it's not exactly that he should have solved all of them. So we have this non-maximality thing that it's okay to have a few exceptions. I'll talk about that. And I will, finish with open issues. What I will not discuss is a recent paper by Joshua Magri that is totally relevant for this, but that's due to time constraints. Okay, so the presuppositional approach was developed, after Loebner by Schwarzschild and also Gajewski. And the view is that the distributivity operator triggers the homogeneity presupposition. And so it's basically, the distributivity operator applies to a predicate, and it returns a predicate that is true of an individual x, of a plural individual x. Oh, wait, this. How did this work? Okay. Well, okay. So it's true if every member, every part of X has the property P, and but then before that you have this presupposition that every part of X, that either every part of X has the property P or no part of X has the property P. So that's basically the same story. And so for the children are not blonde, you get that this presupposes that either all of the children are blonde or none of them is. It asserts that the children are not all blonde, and these two things together you get none of them are. Now, I think there are a number of objections you can make to the view that this is really a presupposition, in the strong sense. A relatively weak objection has to do with the epistemic status of, this alleged presupposition. So, you could have a dialogue like this. I mean, you couldn't really have it, but, it doesn't sound so bad when you construct it. Does John know that Mary either bought all the jewels or none of them? Wait a minute, I didn't know that she cannot possibly have bought just some of them. That's a standard, behavior for the factive presupposition. So that, what I've embedded under no here is, in fact, the homogeneity presuppositions associated with bought the jewels. But if you did Mary buy the jewels, but wait a minute, I didn't know she cannot possibly have bought just some of them, that's nonsense, right? But that's a weak objection because the wait a minute test, it's not clear exactly what it probes. There are various sorts of presuppositions in terms of their strength and so on. So a stronger objection has to do with presupposition projection in quantified contexts. So under the scope of your universal quantifier, a presuppositional predicate P, such as stopped smoking, presupposing little p used to smoke, gives rise to universal projection. So that's a well-established result. So if I say these 10 students all stopped smoking, or these 10 students did not all stop smoking, you get a pretty strong inference that they all used to smoke. Now, let's see what happens with homogeneity, right? So the goal is to construct a predicate P that triggers on its own a homogeneity presupposition H. So P could be read the books. H is read either none or all of the books. And then put that in the scope of a universal quantifier plus negation, because otherwise you cannot tease apart the presupposition from the truth conditions. And so the prediction is that all the A's are not P presupposes all the A's are H, right? So we can do that, right? So these 10 boys did not all read the books. So the predicted presupposition is that no boy read just some of the books. Now, suppose that 2 boys read none of the books, 4 read about half of them, and 4 read all of them. So that's a scenario that does not satisfy the predicted universal presupposition. Now, my point is that in such a scenario, I mean, if that is what you know, there is no, 12 is not infelicitous. If that situation is considered to be possible, 12 is not infelicitous. And furthermore, in such a situation, 12 is clearly true, right? Because as soon as you find, one boy who read no books, 12 is true. A less clear case is this one, and that will be proved relevant. So suppose 5 boys read all of the books, and the other 5 read half of them. Then, 12, I think the truth conditional status is less clear. Of course, I'm relying on introspective judgments. We could maybe test that by more controlled methods, but that's my first characterization of the data. We can look at questions. So if I said, did John stop smoking? That question triggers the inference that John used to smoke. I mean, there are contexts where it doesn't, but that's a pretty strong inference. Did John read the books? Did John read the books? And, I mean, you don't get the inference that if John read some of the books, he read all of them, which is the same as the homogeneity presupposition. Then, you can look at a universally quantified sentence in an interrogative context. Did every one of these 10 boys stop smoking? You get an inference that they all used to smoke. Did every one of these 10 boys read the books? It's not clear at all that you get an inference that none of them read just some of them. And again, 16 clear licenses no. If 2 boys read none of the books, 4 half of them, and 4 all of them. And it's again less clear if 5 read half of the books and the other 5 read all of the books. Okay, so here's another proposal that Krivka made, and which I will argue is nearly right, in fact, right? So his idea I should say everything I say here works only in the context of distributive predicates. Plural referential expressions trigger an ambiguity between an existential and a universal reading. So for John read the books, you have, there are books that John read, that's one reading, and, all the books are such that John read them. So that's the two, potential reading. And then Krivka uses the stronger meaning hypothesis. Basically, so you have a potential ambiguity, you pick the stronger reading, if there is one, the one that logically entails the other one. So obviously in this case, you pick the universal reading. But what's going on under negation is that the strength of the readings is reversed, and so you pick the existential reading. So do I have it here? Yes. So John read the books, so you pick the universal reading. John didn't read the books. Now the stronger reading is the one that negates the claim that John read at least one book, and that amounts to he read no books, right? More generally, what you predict with such a, with the stronger meaning hypothesis is a universal reading in upward entailing contexts and an existential reading in downward entailing contexts. And it works well for universally quantified contexts. So if we look at 22, they did not all read the books. You basically use the existential reading because you are in the scope of negation. And so you get they did not all read one or more than one of the books. And what this means is that at least one of them didn't read any book. And that seems to be okay, right? That's true in that case. Under this story, if 2 out of 10 read none of the books, 4 read half of them, and 4 read all of them. Because you can find some who read no books. What this doesn't capture, among other things, is this non-maximality aspect of plural definites. And for interrogative contexts, given that there is no, at least no natural notion of entailment, you can define a notion that there is no, obvious notion of entailment between questions. Maybe, maybe the prediction is that you will find a genuine ambiguity. And there is an interesting fact that, if you ask, did he read the books? You could answer yes, some of them, and it's understood to mean not all of them, and yet you use yes, right? You could also say no, he didn't read all of them. Then there are, some predictions, and it's not clear about what the data are. So look at whenever my friends visit me, I'm happy. Given that the restrictor of whenever is a downward entailing context, you predict the existential reading. So something like whenever some of my friends visit me, I'm happy, and that's not so bad, it seems, right? But the point is, it depends on which sentence you used, and it's not, so for other cases which are structurally identical, so every student who read the books passed, it's really less clear that this is understood as meaning every student who read some of the books passed. And I'm not exactly clear about what's going on here, and my own proposal will not make different predictions for these cases. Now here is a problem. I mean, there are a number of problems. They all have the same form, and I'm presenting one here. And the problem has to do with a case where a predicate containing a definite descriptions is embedded in the scope of a non-monotonic operator. And at an abstract level, what happens in that case is that the two readings do not stand in an entailment relationship one way or the other, because that's what it means to say that the operator is non-monotonic. So exactly one student solved the math problems. So the two potential readings would be exactly one student solved some of the math problems. So that doesn't even entail that a single student solved all of the problems, right? And exactly one student solved all, the other reading, the universal one, is exactly one student solved all of the math problems. That's compatible with every student having solved half of them. And no reading is stronger than the other one, so presumably, you just predict these two readings. But I think there is a failure to generate a reading that is, in fact, quite salient, which I paraphrase here, which is one of the students solve all of the math problems, or maybe nearly all of them, so putting aside this non-maximality issue. And all the other students didn't solve any of the math problems, or if they did, very few. So in a way, it's as if you want a universal reading in the positive part of the proposition and an existential one in the negative part. But these notions now are semantics. There is only one occurrence of the math problems here, so you cannot it's interpreted one way or the other. Okay, so there is a fix, and that's more or less what I'm going to argue for, but then it's going to get more complicated when we move to these non-maximality effects. you could say, well, actually, what happens is this. A sentence containing the NPs counts as true if it is true under both the existential reading and the universal reading for the NPs. False if it is false under both readings. Neither clearly true nor false otherwise. So you just conjoin the two readings. So when the NPs occurs in a monotonic environment, one of the two readings will entail the other one. And so it just amounts to picking the stronger reading. But for non-monotonic environments, that's different. So the thing is, for monotonic context, we have the same predictions as Krivka, right? Now for this, exactly one student solved the math problems, so we get the conjunction of both readings. Exactly one student solved some of the math problems, and exactly one student solved all of the math problems. That's in fact equivalent to there is a unique student who solved all of the problems, and all the others solved no math problems at all. And that's sort of the desired outcome. Now this is in fact, so it looks very simple, just conjoin two readings. It's in fact equivalent to a kind of trivalent logic that has been used in the domain of vagueness and presupposition, which is called supervaluationism. And I'm just going to say a few things about that because otherwise we won't have enough time. So it's a three-valued system, but whose underlying semantics is fully bivalent. So you have only true and false, and the undefined value is sort of not in the core of the system. So the way it works is that a model M assigns to atomic sentences. So atomic sentences could be things like X read the books in the I mean, it's not really atomic, but I'm treating it as atomic. One of the three values, true, false, or undefined. And then we need a notion. Given a model M, we call M prime is a bivalent extension of M, just in case M prime agrees with M on any atomic sentence that has a standard truth value in M, that is true or false. And for those for which M does not assign a standard truth value, M prime assigned a random standard truth value. So basically, you have, for a given proposition, if a given proposition is undefined, then in the bivalent extension, it has to be true or false. For those that are not undefined, they remain the same. And now we say a possibly complex sentence is super true, just in case in a model M, only if it is true in every bivalent extension of M. So what this means is that even if you have things that are undefined in the sentence, their truth value in a way doesn't count, right? Because however you resolve the uncertainty about the truth value, the outcome is the same. Right? That's the idea, the intuition. And what did I do? So I'm not going to go through examples because one thing that we have is this. So now if we assume, So we have to start from somewhere. So we're going to assume something very close to Loebner, that D read the books is true if D read all of the books, false if D read no books, undefined otherwise. So this is a rule for atomic sentences. And then we apply the supervaluation of semantics. And the point, I'm not going to do that because there is a useful result, which is this. If the NP has at least one occurrence in a given sentence S, then S is super true, given this assumption, just in case it is true under both the existential interpretation for each occurrence of the NP and the universal interpretation for each occurrence of the NP. And that, that follows from a general fact about supervaluationism, and I'm not going to go through it, but you can really think of this as truth on all readings, super truth as truth on all readings. Now let me turn to, so how much time do I have now? 10 minutes, okay. So let me turn to this issue of non-maximal readings. So John read the books can in fact be judged true even if there are a few exceptions, some books that were not read. So you could think of that maybe, but I think that's mistaken in terms of domain restriction or maybe salience. Maybe you pick the most salient books. But the point is that you can say that being aware that there are a few exceptions, but not knowing what the exceptions are, right? And so it's not obvious how you do that just in terms of domain restriction or salience. Now, there is an interesting observation with Malamud. I don't know whether this observation originates earlier. And the observation is that the interpretation of the plural definite depends basically on speakers' interests and standards. So suppose, take the sentence, the doors are open, and, suppose it's uttered by a prisoner who wants to escape, who had a plan, and, he arranged for the doors being open so that he can escape. Then in that context, that's understood as meaning all are open, because, otherwise there is no point in saying that, because it's about the fact that the prisoner can escape. Now, said by a guard, so the guard's role is to make sure that all doors are open. And so the guards, could discover and be in a panic that half of the doors are open, and that's very dangerous. And, after he makes that discovery, he could say, oh, the doors are open. And that would mean, in that context, some are open. That would be true, said by the guard, even though not all are open. So she has a number of cases, and I think the basic observation is correct. So the reference of a plural definite description is flexible and depends on speaker's interest, standard, etc. That's much like, the threshold used for relative gradable adjectives, for instance. Now, she has a very complicated story. And I'm trying to, okay, here is her story, and it has a number of problems. So first, she starts, so you have the NPs. She starts with, so it's my reconstruction. It's not necessarily her words or even her precise implementation, but that's the substance of her account. So she starts with candidate denotation for the NPs, for definite descriptions, and that will be, all atomic or plural individual that are part of the denotation of the NPs, of the maximum, of the sum of the NPs. So it could be any subpart. Then, given a sentence S of the NPs, collect the most relevant candidate denotation. So she has a notion of relevance that I'm not going to go through. The most relevant candidate denotation x1 to xn relative to S. So in this syntactic context, so in the context of the NPs being embedded in structure S, such that interpreting the NPs in S as denoting x1, xi, so gives rise to a maximally relevant proposition. So you look at all the potential meanings that you get from that, and you keep only the most relevant ones, right? But that's not over. And the reason why it's not over, so suppose you are not interested, so you said John read the books, you are not actually interested in whether he read really all of them or nearly all of them. So in her story, if you take, instead of the total sum of book, something a little bit smaller, that's in fact more relevant because there is no superfluous information. But the point is that there are several candidates, right? And you don't necessarily know which ones she reads, right? So what she said, the final story, is that the interpretation of S of the and of the sentence is the disjunction of all these S of x1 and so on. So you have all these subsets of books. Some of that you eliminate because they are not relevant. That wouldn't be maximally relevant according to some definition of relevance. So a few remains. So you get a lot of different possible meanings, and you get the disjunction. Okay, it has a number of problems, but the important thing of that is, so she assumed that phi is more relevant than psi if phi satisfies the address's goals better than psi, or phi satisfies the address's goals exactly as well as psi and is less informative than psi. So the idea is that if you have to choose between phi and psi and they are equally good in terms of satisfying the speaker's goals, but phi is less informative, you should pick phi because that suggests that psi has superfluous information in it. And that's the way, basically, she captures non-maximality. So the idea that if you don't care about whether really that person read all of the books, then you are going to pick a weak reading because that's more relevant because it's less informative but equally well suited to the speaker's goals. And in the view is that in out-of-the-blue context, assume that the speaker's goal is to get as much information as possible. And in that case, maximally relevant means maximally informative. And the hope is that this way, for this case, you derive the same prediction as the stronger meaning hypothesis. In fact, that's not even the case in her story. But I'm not going to go through this specific technical problem here. Because I don't have time. But she has a problem with non-Mondanian environments again, right? Because it's basically a refinement of the stronger meaning hypothesis story. And the problem with this is no matter what the candidate denotations are for the books and only John read the books, there is no way one can get John read all of the books and all others read none. This is so because the box occurs only once, and so it has to be interpreted in the same way in the positive part and the negative part of the proposition. That's the same problem as before. So my proposal is basically to improve on that, and I have to thank Manuel Kretz for crucial insights. So he has his own story, which really has a different architecture, but here I'm using his insights. So the idea is to model relevance independently of informativity by means of partition semantics. Okay, so given a question Q, so Q, divide the logical space, the set of possible worlds, into cells, and when two worlds are in the same cell, that means that they answer the question in the same way, even though they're different worlds. I mean, if you are, that is, you don't care whether you are in this world or the other. So given a question Q, let's say that two propositions are Q equivalent if they intersect exactly the same equivalence classes. Okay, so what it means that from the point of view of the question, they are the same answer. Okay, the relevant information that they contain is the same. Now, the potential denotation for the box in S of the box will be all basically the generalized quantifiers of the form x1 or x2 and so on, where all the xi are a part of the sum of all of the books. So that's similar to what Malamud does. So you get potential denotations. And then, using one of these potential denotations gives rise to what I call here a candidate meaning. If you can find another candidate meaning that is equivalent to that one, given Q, that's equivalent from the point of view of what you're interested in, and that is more informative. So that's similar, to what she did, right? So if it's more informative, but it's equivalent from the point of view of the question, you don't want to use that, right? It's too informative. So now you have a set of candidate meanings, and S of the box is super true, just in case all the candidate meanings are true. And so because we have this truth on all possible meanings, so in out of the blue context, again, we care only about informativity, so that amounts to the same story as before. We can just work with the existential and the universal reading. They are sufficient for all the cases, and we set truth on both readings, so all the previous predictions are kept. But let me take and finish with this. So take the committee members smiled. So you are out of the job interview, and you said the committee members smiled. And that's interpreted as a suggestion that the interview probably went well. In fact, we can assume that a job talk probably went well if at least 8 out of the 10 committee members smiled, went badly if no more than 2 smiled. Let's assume that. And you can't tell otherwise, right? So basically, you are interested in whether at least 8 smiled, between 2 and 8, or fewer than 10. So the partition has now 3 cells, right? And basically, we end up with just 3 candidate meanings. And here they are. So 1 member smiled. That's true in all cells. At least 1 member smiled. More than 2 members smiled. That's true in 2 cells. And at least 8 members smiled, and that's true in 1 cell, right? And all the other potential meanings, are equivalent from the point of view of the partition to one of these 3. And so you select, so you take now the conjunction. In that case, you have entanglement relationship between those, so you pick the strongest one, and that's at least 8 members smile, and that's what you want, right? Now, they didn't smile. Now, the candidate meaning are not more than 2 members smiled, no more than 2 members smiled. That's true in 1 cell. That's the cell where things went badly. Then it's not 8 or more members smiled. That's true in 2 cells. The cells where it went badly and the cell where you don't know. And not 9 or more members smiled, which is true in all cells. That is, if you know that no more than 9 smiled, it doesn't exclude that 8 did, so maybe the interview went well. But it doesn't exclude that no one smiled, so maybe it went badly. You absolutely don't know. And any other candidate meaning, so for instance, take not all of the members smiled, that's equivalent to not 9 or more members smiled in this context. And in that case, the most informative meaning is the red one. And so again, if you conjoin all of this, you end up with no more than 2 members smile, and that's what you want, right? So you do predict non-maximality and sensitivity to contextual relevance. But because you use, a supervolutionist semantics, which is basically something counts as true if it's true in all potential readings, you are fine with non-monotonic contexts. That's the story. So there are a lot of open issues. So one is the source of the phenomenon, right? So I haven't said anything about that. I think, even though I'm really not satisfied with that, so I would like this to follow from very general principles, but I think so far I cannot do with that assuming that somehow the distributivity operator is responsible for that. And the reason that on my story, I can't go through this, but with collective predicates, you get terrible results with this story. So that's one thing. Then you need to extend the story, but that's not so hard, to pronouns, and especially band pronouns, and especially in cases like whenever my children play, they are happy. So here I predict an existential reading for my children. And then, if I treat the pronoun independently, I will predict a universal reading, possibly. But I guess, so I need to say something, so, to adopt some kind of dynamic treatment for an aphora where they will be interpreted as the children who played, either an E-type treatment or a dynamic semantics treatment. So there are issues here which are more or less technical issues. I'm not too worried about them. There is another issue that you lose the homogeneity effects if you add a numeral in the definite description, or at least you can use it for some speakers at least, including myself in French. So John did not read the 3 books. My judgments and that of others is that is clearly true if he read 2 out of the 3 books. The minute you had 3, so so I'm investigating ways of accounting for that. And then there are very complicated issues that arise when you look at the interactions between, so the interpretation of plural variables and plural quantifiers that bind them. It's you get basically wrong results in the story, so you have to do something. I should say that this one is really a problem for every account I know of. Yeah, so I'm done. Thank you. Uh-huh. Yeah.
That he pointed out that he was very skeptical as to supervaluate or certain approaches in terms of, I think it was supervaluation approaches, for the simple reason that when you just look at the number of people, say, have a certain predicate who satisfy, and you say there's a threshold or something, right? Sometimes it's also important what the others do. So here's these examples, like the people smile or whatever. If one of them frowns, right, it makes a difference whether we would be prepared, they were silent or whatever, right? So sometimes it makes a difference what the others do. And if you just say there's a kind of a threshold or something, how many there have to be to get the team credit or whatever. This is, it has to do with relevance. I'm aware of that, but I'm.
No, absolutely. So let me answer that. So can you? I think this is not working. Is it working? Okay. Okay, so the first, it has nothing to do with supervaluations or not. He actually adopts a supervaluationist treatment, but he keeps to Krivka's version and uses accounts from non-maximality in a completely different way. And it's very ingenious, and he may well, I have to say, he may well be right. But the problem, just to repeat it, is indeed, if the professor smiles, if 8 out of 10 smile, but 1, jumped out of the window, then you wouldn't say that, then it'd be, to say that, the interview went well, right? So that's his problem, that the ones who do not have the property, what they do counts in determining whether that's the meaning. And he has a very, very, I must say, extremely ingenious way of capturing that. It's really great work. I wish he were here. I think he submitted it. But I think I have a way of accounting for that. So the thing is, even if I say all of the professors smiled, where there is no issue of how it's interpreted, but in fact one was both smiling and jumping out of the window because he was out of his mind. There is a clear sense where this would be infelicitous. But it doesn't have to do necessarily with the meaning of the sentence. It's just that I'm ignoring crucial information given what I'm interested in. So I think there is a way to to basically, I mean, that involves quantity implicature somehow. So the idea that my candidate meaning could be strengthened into blah, 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 smiled, and didn't do anything else relevant for each of them, right? And so, and I think that could work. It's pretty stipulative, but on the other hand, there are facts beyond that fact that you need to account for anyway, like the one I mentioned about all, you know.
Maybe you were referring to this in your last point of the open issues, but I was wondering how your account would be able to deal with the special interaction that you observe between definites and impartitive constructions, like most of notoriously definites can occur in impartitive constructions, or when definites interact with adverbs of quantification, like, you know, the linguists I know are for the most part nerdy. Yeah. Or most of the linguists I know are nerdy. Yeah. So what kind of treatment would you have?
Or even all of the linguists.
Yeah, sure. Right. I mean, so
the like 3 books. Okay, so for the 3 books, and possibly all of the books, and most of the books, one thing I was thinking is that, you know, the candidate denotation, I could add the condition that they have to satisfy the predicate itself. So if I take the books, you know, my candidate denotations are subparts of the total sum of books, and they are books, right? Now with the 3 books, you know, it's not the case that any proper subpart of the 3 books satisfy the predicate 3 books, of course, right? So if you do that, the only candidate denotation will be, you know, the total sum, right? I think that could work for all of the books under some ways of capturing the semantics of all. For I mean, all these cases. For adverbs of quantification, it's much harder. I don't know exactly.
I have a question that concerns this older proposal, going back to Christine Brisson regarding exceptions. Yep. So her proposal is that this is more directly about the members of the noun phrase denotation. Yeah? Mm-hmm. And I think a relatively good argument for that is if the way the NP comes in matters. Yeah? So for instance, one of her observations is if you say the boys are happy, you're more willing to tolerate exceptions than if you say Peter, Paul, Bill, and Tom are happy. Mm-hmm. Yeah, so which suggests that it's really the noun phrase that is sort of important. And I'm just wondering what your account could do to incorporate that sort of effect.
Okay, so one important observation is that, so in Malamud's story, there is the idea that non-maximality and homogeneity goes hand in hand in the sense that you derive the homogeneity facts from non-maximality, right? This is in fact not, so in fact you can find cases, if you know that there are exactly 2 people, or 3 maybe, and you say, you know, he read these books, there could be no exception when there are small numbers. And so I don't know exactly, but I would say that yeah, the hope would be that you know, when you just single out a small set, for instance, that gives you, and explicitly, you know, this one, that gives you indication about what is the underlying question. You know, if 1 doesn't matter at all, you know, that would be a bit absurd to name that person, but that's really not an answer. I mean, I'm aware it's not an answer, so I don't know. But the hope would be to capture this as part of the story that is based on relevance. That would be the, yeah.
So I was wondering if you thought about the parallelism with, I mean, now with the non-maximality, maybe there is no parallelism anymore, but at least Gajewski treats this homogeneity effect in parallel with neck raising. Mm-hmm. And I was thinking, I was wondering whether you thought about how you could apply your system to that.
Yeah, so first I think it's very parallel. So, I mean, as a background, you know, neg raising for some verbs like believe was accounted by Gajewski in terms of a homogeneity presupposition. So the view is that, you know, John believes that P is really the worlds compatible with my belief are P, so it's a plural definite description. And so now when you say they are not P, it's not the case that these worlds are P, then you get the homogeneity effect, no world is P. No world compatible with my belief is P, namely I believe not P. That's his ways of deriving. So in principle, I could, of course, adopt I mean, I could have the same analysis, you know, that is treating more or less, you know, believe as some kind of plural definite, I could always do that, right? Maybe the story is really different. Maybe it has to do with gradable predicates, so which I think follow abstractly the same logic that is the logic of supervaluations. So, tall means, higher than a contextually determined threshold, but not tall doesn't mean, below the threshold, but, way below the threshold to avoid, uncertainty. So, you are clearly tall if you are above a certain threshold, and clearly not tall if you are below a certain threshold, which is not the same, which is significantly lower than the threshold for being tall, right? And, again, a supervaluation treatment for tall says, truth on all reading, that is, you interpret tall with all conceivable, with respect to all conceivable thresholds, and you say everything is true. For every threshold, the sentence that contains my predicate tall is true. I'm mentioning this because you could possibly give, view believe as a gradable predicate. It can be modified, I strongly believe, things like that. I mean, so if you view it as a gradable predicate, it would fall under the case of tall, but it's hard to do that and preserve, things that we won't preserve about the logic of belief. But did I answer your question? Yeah.